I am a director at Quicken Loans. I lead 3 different teams there that help with the mortgage process. You can find me on social media at any one of these points at J Guadagno, Joseph Guadagno Net on Facebook, LinkedIn at Joseph Guadagno, or if you want more on any of these topics or anything I blog about, go to jjg.me/aboutjjg, or essentially my full name .net. So I expect a whole bunch of followers and Facebook requests after this, as usual. So, if we look at the overall set of events so far, we started off with a great introduction on what an architect is, and there's many differences around what an architect is, and every organization has a different opinion, and there's different types of architects, which we've kind of seen. We talked about enterprise architects, and then some solution architects and technical architects. Then Andy went and took it to the next level and talked about some principles. Principles are general guidance around it. I'm going to sit here today, or stand where I'm standing right now, and talk about patterns. These are ways that you can implement some of the principles that Andy talked about. And these patterns work with web, non-web, and pretty much life in some way, shape, or form. And it's really distinct. One thing I want to point out with this is that these patterns and principles that we've talked about so far today are our versions of them. One of the things I've learned in the 2 years I've been in software development, multiply that by 20 or 10, every place is different and every person has their own opinion. One of the things Andy said a lot in his was, this is how I do it. This is how our team does it. And that's an important aspect of it. If you look at the overall principles, they are principles. They're not directives. They're not mandates. These are principles, guidelines, I like to say a lot with it. The same thing holds true for patterns. Patterns in software development help you out in several different ways. And I got to move one of my screens over a little bit. They help you out by putting together the building blocks. So when Mahesh and Magnus started talking, they talked about how we build a house. Software is like building a house. You start off with a foundation, which are the principles or the guidelines to it, and then patterns for building the house. What do you do? How do you do it? Do you put the concrete first for the foundation? You put up the studs next. You put up the plumbing? The order of things and how you do it matters to make it repeatable. The reason why you make it repeatable is so that you don't make mistakes that you might have made in the previous. So we're going to cover some of the most common patterns that are used. Again, a lot of these are my viewpoint. Your mileage may vary. But the primary purpose of a pattern is the age-old adage of don't reinvent the wheel. Patterns exist to help you create and redo things over and over again, so you're not making the same mistakes. So let's take a look at some of them. The first one that you see is the commonly referred to as the layered approach, or multi-tier / 3-tier / n-tier. There are lots of different names. I know back about 20 years ago, we talked about how everything had to be n-tiered or 3 tiers. And this is the common breakdown for it. You have your presentation layer on top, and this is your mobile applications, web applications. These things talk to a logical tier. The logical tier is where all your actual work happens. Things like how to place an order, how to ship an order, how to deduct items from the inventory. And this layer talks to the data layer, which is, okay, now I got my inventory. Where do I save all this stuff? How do I check my inventory, etc.? One of the things I want to clarify with this is that there's a difference between tier and layer. A tier is typically designed for the actual implementation. So data tier typically has to do with, you know, the database, the storage, where logical tier has to do with the business rules. Layers can be a lot more than that. You can have more layers that sit in there. So from a logical tier, you can have one layer that handles all the requests coming in, that does things like validation, things like that, that hands it off ultimately to another layer that goes and does the actual processing of it. So it's an important distinction. They get confused a lot between themselves, but they're really not that different in most cases. Some of the advantages of using this approach for it is it really helps with the first of the solid principle, or not really first of the solid principles, but the separation of concerns. Separating out your presentation so that you can handle your user interface. The deadly question of what about handling logic in stored procedures? I'll get to that in a little bit. That's the age-old debate. As long as I've been doing software development for 25 years, where do you put it? I'll cover a little bit of that in the event sourcing portion of this. You have the ability to minimize your dependencies. So as you start pulling out the layers of the onion, they're less dependent on each other. It makes development a little bit easier because people are used to it. It's been around and commonly used for at least 20 some odd years that I know about. Also makes your application a lot more testable, meaning that you can with the pieces separated, like if Andy's demo where you had the validator, you can test out the validator separate from the piece that actually goes to the database and saves it. And then it's reusable. This logical tier, the data tier, can be propagated to other applications without having to worry about the presentation model. There are some disadvantages to it too. It's like the changes that happen. Let's say you decide you want to add a new column. You have for a person, you have first name, last name, and date of birth. But you decided, since it's an ordering system, you want to know their anniversaries so that you can send them a happy anniversary message. You have to go and make modifications all the way up to all the different tiers. So your presentation has to have a new field, the logical tier has to have a new field, and the data tier in most cases. This also leads itself generally to having to write more code because you separate it out, which is going to be a common theme throughout lots of these patterns. And then you have the age-old debate that came up with one of the questions: where does the code go? Do I put my business logic in a stored procedure? Do I put validation in the presentation tier? Does it go in the logical tier? Where does it all go? I say it really depends. Like Andy said, it's up to you and your organization. For me, I prefer to not have any database, or sorry, any business logic in the database. And I use the word prefer on purpose. Like Andy said, we prefer to use an ORM than stored procedure. Sometimes it makes sense to do things in a stored procedure, especially if you're doing multiple joins, multiple queries, summarization, it makes sense. Same thing with the presentation layer. With validation, it makes sense to put the validation in the in the presentation layer. It also makes sense for it to be in the logical layer because you don't know how the data is coming in. So you stop it at both places. And yes, it violates the dry principle to some extent, but in each different layer, there's different sets of data coming through. Plus, there's also different ways to handle that data. In a presentation layer, you might want to have a drop-down list to choose a state you're from or a country you're from. Whereas in a logic layer, you don't have that. You just want to say what, just validate that it's a real country. So again, it depends on your preference. Next up is the model view star. And the reason why it's a star is because there's really 3 patterns here that are commonly used depending on the implementation and the framework you're using. The most common one, which Andy used and stole my thunder for, thank you, Andy, is the ModelViewController pattern. And it's kind of highlighted here. The idea is you have this model which sits on top. The model describes your data. So we sit in the order concept, has your order details, products, that kind of stuff. We get a list of orders from our controller, which is this guy here. Our controller sends the model upwards. That model goes to the view. The view then takes it and the user sees it. The user does certain things to the model, like adds an item to it, creates it. It goes back to the controller. And then the cycle keeps going. So the controller itself has all the brains of it, what to do, how to do it, knows how to go to database, how to validate it, how to pull records. The model is just concerned with its models. So if we go to the person that ordered, first name, last name, date of birth, does the validation for that. The view says, I know how to handle this model and display it. And then the user is just there to, interact with it. Some of the advantages of the model view controller are more so to testability is probably one of the biggest. The view part becomes very helpful if you're in a larger organization and you have people that specialize in user interfaces, where you might have a person, like Andy mentioned, with the marketing department that is really good at CSS or understanding design patterns. And I'm talking design as in user interface design, where they can go and design an application that is user-friendly. Because to be honest with you, most engineers that are quote-unquote full stack are not great at design. We can get by our toolkits, whether you have .NET or Java, have some good out-of-the-box stuff. But, for most of us, Battleship Gray is our default theme. One other advantage of it is that the presentation becomes more reusable. You can take out those views and have different vantage points of them, or different versions of the view, as well as be able to test out the views, test out your business logic layer, aka controller, test out the models a lot easier. There are 2 different variations of this. The presenter model, which, let me clear this screen out. Where's my escape key? I don't have my escape key. Or I can just hit forward. My PowerPoint skills are failing. I will just, no, I don't want to end show. Sorry about that. I broke PowerPoint. Let me restart it. I shouldn't have done the annotations part because I knew I was going to get it messed up. So the presenter part, or the model view presenter, really follows the model view controller The only real difference is the presenter. Replace the controller with the presenter, and the presenter piece handles the interaction between the view and the model and the user. There's some other smaller variations of it, but that's the overall gist of it. And then you get the model view model, or commonly referred to as MVVM. Same principle. You have your view, you have your model, and then you have the view model, which does all the interactions. So it just depends on the framework. I know if you do a lot of Xamarin or a lot of WPF, Windows Forms, the MVVM model is super, or pattern is super popular in that. Then move over to our next pattern, which is event-driven, commonly referred to as event sourcing, publish, subscribe. Names vary depending on who you talk to, but I'll use the event-driven. The event-driven takes everything as an event. So your code does something based on a given thing that happened in your environment. So as the sample shows you on the right, when an order is placed, I do something. So we trigger an order place event, which goes out and charges my account, does an inventory check, not necessarily in this order, make sure that the item's there in the inventory, then goes and deducts the item from it. Once it deducts the item from it, that may in turn trigger another event called the order ready. Now that the order is ready, I know I need to ship the package, then update the order. The event-driven model is really helpful when you have larger systems that are a little bit more complex. This allows you, and this is commonly used for order processing systems or anything where you have a lot of transactions. If you think of it, when you place an order on Amazon, Target, Walmart, you name it, when an order happens, there's so much that happens behind the scenes. We go and make sure that the product is there. We check for shipping. How quick can that product get to you? We deduct it. We have to charge a credit card. We have to make sure the credit card is charged before it comes back. Here's where the event system comes in. We're going to talk about how that plays into the next pattern. But one of the things I talk about a lot is that you'll see a lot of these patterns throughout everyday life, for that matter. Think of a phone call, for that matter. When a phone rings, I know most of you young kids don't use phones anymore, you text, but when you get a text message that comes in, your device beeps. That's an event. Something happened, which triggers a response from you to go and grab your phone and look at it. We use this pattern a lot just in software development and in life. And there's many different ways to implement this pattern. Usually you hear the most common implementations are using message queues or message topics, things like Azure messaging, Azure Service Bus, Azure Event Hubs, or if you're an Amazon person, their simple notification service, the simple queuing service, event bridges, or IBM MSMQ. There's lots of different implementations about it. Messaging has been around for quite some time. With the advent of the messaging, we have kind of a piggybacking pattern called CQRS. And I know this interface doesn't really match the color scheme of the rest, but the next two slides, it was really challenging to get in that small space everything that was needed. So CQRS, or referred to as the Command Query Responsibility Segregation. In a nutshell, the pattern has us separating out actions versus querying. So if we go back to our order system, the fact of going through and creating an order, which is a command, should be different from going through and reporting on how many orders do I have, how many things like that. So separating out the two. Common pattern for this is a reporting database. If you have a high transaction system, a lot of times the system that's writing out to the data store is very different from the system that's reading it. And a lot of times you have a replication database set up where you're writing, I got to imagine it's something like an Amazon, they're writing out records, millions and millions at a time to a database, but someone that's looking for inventory reports or seeing what the sales threshold was for the day is pulling that data out from a separate repository. And that's a good use of the CQRS pattern. Have your commands separate from your queries. And you can see that on the diagram. If you look at the user interface, starting at the very top with the yellow, we go through the command bus. So in that order of Amazon, the create order. The command handler says, okay, create order. I need to go to charge the account, check the inventory, go through all those lists. And it's not just one item. Usually one command will fire off more than one command. So if you think about it from the event-driven, when we placed an order, we did an account charge, an inventory check, a deduction. In the event-driven pattern, these are different events. In the CQRS, these become commands. So we have an order place command, which then creates a account charge command, an inventory check, etc. So it's often that these kind of get a little mixed together, which we'll see in a slide or two. And then those commands do stuff with the different domain models, the customer contact, the order, etc. And then come back to the event database. And then on the side of that, we have the event bus, which is writing off these events that are happening. And these events are typically database updates, things like that, to something else that sits in the query part. So we go down the right side of it, which I think is your left side on the screen. When we're looking for orders or status of an order, we're actually not doing the commands, which is this side. We're going down the pipeline and creating a query, going off to the data, reading the data. Another good way of looking at this is when you're on Facebook or even this chat thing. When you're sending a chat on this stream, it's not necessarily writing it off to a database. Once it's in the database, going out and broadcasting it, it's sending an event. It's sending an event off to some backend system that says, hey, there was an event that happened. Someone created a comment. That comment then goes out to a database. So a command handler is writing it off. At the same time, something else is saying, hey, publish this content for everyone to see. So there are some advantages and disadvantages to this particular pattern. It allows you to handle very complex applications. Again, you go back to that ordering system, where if you're doing a basic console app, this is way overkill. Even some standard basic CRUD applications, create, read, update, delete. If you're not doing a lot of high volume, it doesn't really pay for this. Can dramatically improve performance, especially if you're just farming out or shipping off some of that content to others to use. It also makes security a lot easier, and the way it does that is separating some of the concerns. You have people that can query, people that can write. Most people don't need write ability. It's usually a system that needs the write ability. But it also has some pretty big disadvantages. Can be overkill, like I said, for a basic CRUD application. For those who don't know, CRUD is create, read, update, delete. So your basic like contact application. The data itself can run stale. So if you think about it, if your system is not designed, everything that appears on the left of this diagram, the command side, depending on how often it writes in that repository, the darker blue is synchronizing with the event bus, that data can become stale. So you have to weigh those balances. And how you synchronize that data becomes a challenge. You have to weigh the pros and cons of how often you want to synchronize it. How quickly does that comment need to show up on a screen, or how quickly does it need to show up on some report? In the real world, quote unquote, whatever that may be, you see the event-driven or event sourcing and CQRS patterns combined a lot. On this diagram, you'll see on the left-hand side where it says event store. A lot of the times, I should have actually flipped this diagram over, but from the bottom up this time, you have our client sending requests, and that request is going to the command handlers to generate it. So the event to create the command to create an order is going up on the left-hand side. The repository is then going off to the event bus, similar to what I said earlier. And then those different events are triggering the storage of those, where another user can come and query out those items. So you'll see this pattern mix a lot interchangeably. The next pattern up we talk about is the plugin, or if you're doing operating systems, the microkernel approach. Think of the plugin approach as you build out your application, this center ball, and your application has multiple pieces that plug into it or are part of it. You have an order component, you have an account component, an inventory component, and a shipping component. It goes towards Andy's example with the join the group. There are 4 different things to group. He essentially created plugins for each of those. But this plugin is a little bit different. This one is actually adding in individual pieces. So if you use Microsoft Outlook or Teams, or most major applications have some kind of plugin infrastructure to it to add in the latest gifts. If you have Slack, you have the ability to add in something from Jiffy. You have the ability to add in your Git notifications via plugins. This is a very common pattern when you are building an application that you are selling. Think of Visual Studio for that matter. Visual Studio is one gigantic plugin container. Every little facet of Visual Studio, from the Solution Explorer to the Git integration, is a plugin. There's a reason why it's a 5 gig download, because it's downloading thousands of plugins to go across. One of the biggest plugin ecosystems that you use on a daily basis is the operating system. The operating system is not just one gigantic code base, but one small code base that runs multiple plugins all throughout. You have your device, your individual devices. Each device is a plugin or an adapter to it. Another common example for this is a task scheduler. You want to add every hour you want to run this particular thing. Well, that particular thing is a plugin. Things like Azure Flow or Microsoft Office Flow help you with that, and Lambdas help you with that a lot too. So plugins are generally used when you are building an application that you want to have extended, and usually extended by someone that does not have access to the code base, meaning I'm publishing this out for a third party use like Visual Studio, and then others can improve it. Whereas when you're writing stuff in-house, you typically don't use the plugin pattern because you can modify the code. But if you know things are going to be changing, plugin pattern works really well for you to be able to provide certain functionality to your system across the board. So like maybe an admin module that you can plug in and it gives you different rights in the screen. Those are different ways to use the plugin pattern. Now we're going to step into probably two of the most common modern plugins or common modern patterns that we use. First one is the service-oriented pattern, aka SOA, aka microservices, aka any new buzzword in the last 5-10 years. The concept behind service-oriented architecture is just that it's service-oriented. So if you take our inventory or our ordering system that we've been talking about, you have this listed as Acme widgets. Acme widgets has the ability to provide off those services. It has an account service, an inventory service, a shipping service, an order service. These are total of 4 different services. They're all independent from each other. They don't know about the next service. And then the Acme widget says, well, when I need to place an order, I need to go and call the account service to see if the person's in good standing, if I can charge the account. Then I need to go and call the inventory service to see if they have any of the products in shop. Once they do, I then need to call the shipping service. Say, okay, go and ship these items. Now that it's there, I can update the order by calling the order service and says, yes, your order is there and ready to go. So what makes this pattern so appealing is that each of these small pieces are not necessarily small. In this particular example, we'll use small. Each of these are independent services and capabilities that allow you to segregate out the responsibilities. I just want to do account servicing. I want to be able to check up who a person is, charge cards for them, generate reports on that particular person. The inventory service is just responsible for removing items from inventory, checking the stock of inventory, validating whether something is there or not. Same thing with the shipping service. So now we're starting to peel apart an application in order to make these smaller, more fine-grained implementation details around it. So how we go about creating an account service. This allows you to also start breaking down your application, but also breaking down your teams. I work for a very large mortgage company. Andy works for a very large insurance company. I'm sure there is not one developer that knows the entire ecosystem of everything that happens. This allows us to create specialties or sub-teams within an overall larger team to break down applications and have a single responsibility. Within our organization, we're not giving you a lot of details into how we're broken up. We follow something called the release train model, which is very similar to service-oriented. We took our technology team and split it up. We have 2,400 people in technology, and we split them up based on how they do things. So in most organizations, you have a security team, you have a support team, you have an engineering team, and so on and so forth. We have that separation. But then even inside of that, for our engineering team, we split up our engineering team into 42 sub teams. That allows us to really specialize on something. Like I focus my team on everything that are related to fees. Other teams are focused on just the documentation, how we provide documents to clients. Other teams are focused on the user interface. So not only can you do service-oriented within software, but it's also possible within an organization. And if you think about it, your house is very service-oriented. You have a group that manages the water for your house, or at least in Arizona and most of the US you do. You have a separate group that handles your electricity, a separate group that handles property taxes, a separate group that handles utilities like gas and electric. So we've broken out, the world, so to speak, in service oriented. So it's super common to see that in software nowadays, and things like Azure and AWS and Google Cloud make it really easy for us to do that. Speaking of Azure, Google Cloud, and AWS brings us up to our next pattern, which is all the buzz right now, serverless, aka the cloud, aka not on my PC. And I think the not on my PC is really the important part of this overall concept. And the idea is that this is running on someone else's machine, not the admin for the CEO, not hopefully underneath your desk, which has happened in the past, but there's someone else managing the server. In a lot of organizations, you have a data center. It's very common with serverless, where it's there, and someone else is taking the load of managing the operating system updates, security patches, making sure the network cables are there, et cetera, et cetera. This takes it one step further. So with the concept of serverless, you'll hear things like function as a service, software as a service, et cetera. They're really not servers themselves. They're mini processes. If you think about the service-oriented, these are individual entities that we have listed. In the serverless world, these are individual functional programs that are running. In the AWS world, they have Lambdas. Google has Cloud Functions. Azure has Azure Functions. These are sections of code that are running and just running one thing and one thing only. So if you think about Andy's example where he did validation, have one little thing running validation, one thing running emails, one thing running notifications. This is where the serverless comes into, breaking out your application into smaller individual pieces so that they can handle the load, and it takes it out of your application. This requires a lot of forethinking about how you're going to do it. If you think about going back to here, each of these different services can be their own serverless implementation. You can have an account service endpoint that is serverless, meaning it's just running in a Lambda to handle the request, and then the back end goes through and handles everything else. So with that being said, a lot of these patterns are here to help guide us in software development, kind of help us rebuild things in a repeatable way so that we are not reinventing the wheel, like I said earlier. But with that in mind, you look at your toolbox, and there's an age-old saying in the software industry, if the only tool you have is a hammer, you tend to see everything as a nail. So the reason why I gave you, I think it's 12 different patterns here, is there isn't a one size fits all with software patterns. Just like there isn't a one size fits all for principles. You have to do the collection of them. Sometimes your application might make sense to just be model view, but other times the CQRS pattern might make sense. The understanding is to create something put in your toolbox something other than that hammer. Put a screwdriver in there, put a saw in there, put a wrench in there, put all these different design patterns. And I know I described them in 5 minutes or less in most cases, but it's a good starting point for you to understand what you have across the board to see how you can use and what makes sense to apply to solve your problem. Because if you think about it, hammering in a nail, the hammer is a solution to the problem because you don't really want to push that nail in with your finger, but having the right tools in front of you helps you to solve the problem of what software is trying to solve, which is typically a problem. With that being said, I am ready for questions, and I don't know if we are doing questions or saving them for the end. So let me pull up my screen. I see one in there from a tool. I should probably hide that. And no one cares that I have bill pay today or tomorrow. Let's pull up this slide. How does MVVM compare to MVC? I'll leave all this up here so we can see. Since that one was brought up, I'll bring up this slide to kind of show it. I don't know why I have two slide decks, but essentially MVVM and MVC are very similar. The only details are really different is the controller part and the view model part. MVVM is used a lot in systems that are self-contained. And what I mean by self-contained, they're typically things like phones, or when you're concentrating mostly on the user interface, where the ModelViewController portion is usually done for applications that are spread out where you want to have different things about it. So one way I like to look at it is the MVVM model could be used for building out the mobile app. So if we go back to our ordering application, we might have a mobile app. So Amazon has an app that works on an Android and an iOS device. Inside that application, they're probably following the MVVM pattern where their view model is going out and pulling the data back from the physical backend repository, where that backend repository is the ModelViewController, which is saying, okay, I'm going out getting that service, and I'm going to return this model via a view to the mobile application. But that same view can also be done on the web application for if you're in a browser or not. I think there was another question around, let's end the show. Is it necessary to have domain-driven design for CQRS? Can CQRS be applied to simple 3-layered application? Can I apply event sourcing to my 3-layered application? Wow, that was a lot of questions all in one question. The nutshell is yes. Again, like I said, a lot of these are individual patterns and preferences. They're not hardcore solutions. So if you look at the example I gave originally with an order, especially with CQS, you can say that I want my events to trigger a certain action. So if we looked here, we have a indication that our orders placed is the actual event, then it goes back out to do it. So when we are calling here, we see our user interface can set a command to go and call the command handlers and go all the way down while still keeping this out. So from the 3-tiered spot, if you look at this diagram here, everything in yellow is the tier 1 or the first layer, the presentation layer. Everything from the command handler domain is the middle tier or the logic layer, business layer, service layer, whatever your term is. And then the last is the repository layer. And this uses events all together. So like I was saying, not every hammer, not every nail needs a hammer. You can actually mix and match a lot of these patterns. You also asked the question of how SOA is different from microservices. They're interchangeable. Microservices is just trying to get it to a lot smaller content within your application. And I see Magnus.
Yes. Hello.
We are here. You continue your questions.
Yeah, go ahead.
They're not my questions; they're the user questions.
Yeah,
I have no questions. I know all my content.
You got a lot of questions because you put so much. So many patterns in there that a lot of people went crazy on the questions, that's a good thing.
Yeah, when I went to full screen with PowerPoint, I lost all the questions, so I couldn't see them all.
Of course, yeah. No, we could. I'm sure we could spend a couple of more hours just talking, just hashing this out endlessly. We need some form of beverage to do that, I'm sure.
Yeah. So can I apply the event-driven pattern and domain-driven design? Yeah, I think I just answered that with the last question.
Yeah.
I will put these slides up on.
Take one more question up.
I hate the CQRS. The query here is only for fetching information or kind of post data as well. You typically don't want to post. That's why it's command, query, and read is the R part of it. That's usually only for the querying. If you want to post any data, you usually should have a command for that so the proper events can fire throughout. And I will post these on my blog at some point, and they'll be in the GitHub repo. But I have all my.
That one is a very interesting technique. In the scenario where it applies, it can do a lot of fun things. It can really help you scale your application and so forth using that particular pattern.
Yep.
Okay, so thank you so much for being with us. That was a lot to take in, and that's the intent because there is so much to uncover in this field. And I saw from people in the questions that they were like wide-eyed, doe-eyed people listening to you.
Good, I hope.
Yeah, no, it is great. Are you gonna stick around for the panel a little bit?
Yeah, I'll be watching that day until.
Okay, good. Well, we're gonna continue. We're gonna squeeze in one more topic before the panel, and so now we're off to Cloudland.